So I think now we are ready to uh, implement our first IoT Internet of Things project. Uh, so what this should be. I mean, I've thought a lot about it, and I thought of different things that we can have. Maybe some small tiny Android device, and then we have maybe a certain gateway in between, and then a server. But then I thought that let's keep it simple so that it is easily understandable, and you got the concept, the concept of what an IoT ecosystem actually is, and it and how it works. You get this concept completely, and then you can apply it to any kind of devices, maybe Raspberry Pi based devices, or gateways, or Arduino based, or and cloud based uh, IoT ecosystems. So what we use for, first of all, what we need in an IoT system, we need in any IoT system, we need we need these sensor devices or sensor nodes. We need these sensor nodes, and then we need a gateway. As we said, we have already discussed these things, is communication between the two, and then we have a cloud or server, server. So in our case, we are going to use this our personal computer as the server. Server is going to be our PC, and our gateway is going to be our Android phone, because normally there is Wi-Fi, or as we said, Wi-Fi or GSM or UMTS, communication between these two, or and so we can use, for example, here we have all these capabilities in our Android phone, so we can use here our Android phone as our gateway. Okay, this is our gateway, and we can use the sensor nodes as those sensor devices that are present within an Android phone. All of Android phone has teeny sensors in phone, in mobile phone, uh, in smartphone. Okay, smartphone. So we can use, so instead of this model, we use the model in which the sensor devices are inside the gateways. Our sensors are here. So we have already discussed this model as well, in which the gateway and the sensor devices are located in the sensor device is already located inside the gateway. So we are going to read the value from the sensor devices, send this value to the from the Android app, storing it somewhere, and then we send it through we can use Wi-Fi or GSM or UMTS, whatever, but we are in simple, we are going to send it to the server, or this is going to be our cloud. We don't need to have a web application here instead of the in the server. We can have a web application and use this HTTP send and get post and all those things to receive the data or send the data back, send the acknowledgement back. But we will just use maybe some small Android or a Java application which is going to receive the values and and send an acknowledgement back, or just display the values, just this. So this is going to be our project. We can again describe it here. It says that the PC will act as a server, the personal computer. Android phone will act as a gateway, plus also the sensor device. So data will be read from the sensors inside the Android phone, which is going to be contain our sensor device. and then this data is going to be sent to the sent from the phone, the gateway, which is also the gateway, to the server, which is our PC. So again, I mean, PC, the personal computer, is going to be our server or our cloud. The Android phone will act as a gateway plus the sensor devices, as we described here. It's going to be, the phone is going to be the gateway plus the sensor devices that are located here, all those sensor devices like temperature, pressure, accelerometer, proximity, rotation vector, orientation, all those light sensors that are located on our Android phone, plus the Android phone, which is going to contain this app, which is going to read this value from the sensor. All this is going to act as a gateway plus the sensor device. So after getting the right values, processing the values, if we want, we are going to send these values to the server. So as it's described here, data will be read from the sensors inside the Android phone. So these sensors are also the sensor devices inside the Android phone. Data will be read from them, and it's going to be sent from the gateway, which is again the same Android phone which has the sensors. So it is going to be sent from the Android phone to the server PC, which is our cloud as well. We can call it cloud, we can call it server, it does not actually matter. So this is going to be our first Android IoT project that we are going to implement, and I hope you will understand this. Again, I can describe once more. For example, we have described two kind of topologies, right? One of the topology is this one, in which the sensor nodes are separate. In between is a gateway, and then we have this. This is our cloud. So data is then the values are read from the sensor nodes. They are sent to the gateway. On the gateway, which can be anything, our phone, it can be a Raspberry Pi or Arduino based gateway. This is going to process those values or filter them and send them to the cloud. And in the second topology, we have these sensor values, these sensors, these sensors, we are going to have them. Let me use this red marker. We are going to have them inside the gateway. So this was our second topology of an IoT ecosystem that we have described before. So gateway and the sensors are located on the same device, and then the value is read from the sensors, or the same device is going to read the value and also send the value to the cloud, and receive acknowledgement or whatever, and this is the second topology. So we are using, in our case, because all of you or most of you have Android iPhones. If not, you can get it from some friend or something, and I hope all of you 100% have a a computer as well. So you can make a server on your computer, and you can run a client app or develop a client app on your Android phone, which is going to read the sensor devices values from more than one sensors or only one sensor device, any temperature, pressure, accelerometer, gravity, orientation, proximity, whatever, and read those values. This app is going to read those values and also send those values to the server. So that's why. So I think choosing such an IoT project as our first project is very good, because we have the equipment, we have the phone, we have the server, and we can simply write for example, a Java code on the server side. Maybe it can be an Eclipse, it can be also in Android, but we can write in Eclipse if you think it's better, and then we can write an app in the Android Studio, and then store it in our phone, and then do the communication between our phone and computer. For the first, we can also only simulate it. We can do it using Android Studio and Eclipse. Hi, so now we will talk about sensors, how to program sensors. Let's click on new project. Sensors, as we talked about, that sensors can be separate devices or they can be located inside our gateways. So we will consider the sensors that are located on our mobile phone device, say an Android device, and we will find out how to kind of get the values from those sensors and print them on on an on a computer on an app, on a UI for an app, or send them to how to send them to a click on Android lectures, that will be our location to save, or how to send them to a server. So let's name our application as sensors. Sensors source sensors project. Sorry. Click next. Okay, minimum API is 15, Android 4.0.3, ice cream sandwich. Next. Choose an empty activity and click next. Name it not the main activity but sensor activity sensor, and click finish. And now we got to wait a bit and until it loads the project. So the project has loaded. Now what do we need? We should go to resource, layout. Here we have text view already in. Let us change the layout to a linear layout. And let's give it a name. ID is, let's say, main layout is the ID. Control S. Now we have a text view. Let's give this text view also a name. It should be list of sensors available. So this text view will give us a list of available sensors. Name it as list of available sensors and give a text, the display text as list of available sensors, and then we constraint. So I mean we don't need to, it will be just below the, it will be the first thing on the top of the UI. Now the next is we need list, a list view, and this list view will give us no, first of all we just stop here with the layout and we try to print the list of available sensors on our UI. Let's see how to do it. Let us declare a text view here, that is text view is available available sensors, and then we go here, AVAI available sensors is equal to text view and we will now use the find view by ID function and find the list of available sensors, text view, From the main layout, we will load this ID, this sensor using find view by ID. We will find this view, the text view, and assign it to our text view variable that we have defined here or declared here, that this is available sensors. Now, next. Now, to get a list of sensors, we need to get the sensor manager class. The sensor manager class will use sensor service to kind of get a list of sensors and uh, get system sys get system service, and then the string name is sensor sensor service to get a list of sensors and show them on the UI. We can make it a variable sensor manager, and we can define it here, sensor manager sensor manager. This is just the object of the class sensor manager. Now we need a list. So we define a list of sensors. Sensor class, it contains the types of the sensors that we have. You press Alt Enter and you will get the import class Android hardware for sensor and Android hardware sensor manager for the sensor manager. Now equal to sensor manager. The sensor manager class object uses the get sensor list, and in this you have to give the type, for example, the different types of sensors, pressure, temperature, ambient temperature, acceleration, gyroscope, light, whatever sensor type you want to give it here you can give. But we can also, for example, TYPE underscore, sorry, we have to use the name of the sensor class first, dot type. You see, ambient temperature, ambient pressure, sorry, pressure, type proximity, type acceleration, type all. We want to right now select all of the temperatures using this service, sensor service, and list sensors. We can also declare it outside our own create function, and we can use the list sensors, list all sensors. Variable, list variable. Now we can simply loop over all these sensors, this list of sensors, for int sensor ID is equal to 0, sensor ID is less than list of sensors dot size, because this list now contains all of these sensors which are contained by our mobile or our emulator. This by giving this parameter type all, we have got the list of all of the sensors in our Android emulator or Android phone, and we have stored this in this list variable list all sensors. And then we have the next one as sensor ID plus plus. And now we have these braces, and now here we will use our text view, available sensors, view. We can call it available sensors view. Available sensor view dot set text, and we can say sensor, let's have this sensor number, and then we have this semicolon, and then we can use plus sensor ID, and we can again use plus a space, and then we use our m list sensor dot get. We get the index, we get the sensor at each index, or actually get name dot get name. We get the string name of the sensor, and that's it. This is going to append this sensor text, this text view for the sensor with with one by one. For example, it will say sensor number 1, and then write its name. Pick the list from the index 0, and then from the index 1, and from the index 2, and like this. It is going to fill all the our UI with all the available sensors. Now we run our project. We have to select this one. This is our available virtual device, Nuxx 6P API 25, and we run it, and then we wait before the APK installs and our emulator gets up and uploads, and the UI is visible and loads the app, the app UI. So our app is now running, and we see here we have only the sensor number 13, orientation center sensor here. Yeah, so this must be the 13th one. So I know what the problem is. The problem is that we don't need to set text, because set text always replaces the old text in the text view. We need to use the append. So now if we run it, it will show a list, because it will just extend append the previous text inside the text view. And now we have to wait a bit. Yes, now we have list of available sensors. Sensor number 0 is accelerometer, and then X is gyroscope, magnetic field sensor, sensor number 3, sensor number 4. Yeah, so but the problem is that they are all one after the other. There are no lines. Now first of all we should start with 1. So sensor ID plus plus should be here, because it will be one more. The counter will start from 1 now, not from 0. And the next is that we need to have a new line. So we just add another plus sign here and a new line at the start, /n, not this slash, the other slash, this one, sorry, /n. And now we see what we get. Again, we run it. So now you see we have this 1, 2, 3, 4, 5, 6 orientation sensor. They're all in different line lists of available sensors on the top, but still we have Now the problem is once the sensor ID is incremented here and then it's incremented here, and then we always get from 0 to 2 and 4 and like this, we are skipping one sensor, a sensor in between, the sensor for an index for the list in between. So we need to remove this, and we need to run again, and now it will print all the sensors. The app is loading. Yes, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Accelerometer, gyroscope, magnetic field sensor, orientation sensor, temperature sensor, proximity sensor, light sensor, pressure sensor, rotation vector sensor. One is geomag, one is GAM, rotation vector sensor. Gravity sensor, linear acceleration sensor, rotation vector sensor again, and orientation sensor. So we have these 13 kind of sensors available in our emulator that we can see also from here. Go to virtual sensors, and we have all these accelerometers and magnetometer and rotation here, and then these are additional sensors: ambient temperature, proximity, pressure, magnetic field, light, and relativity. And you can change the values like this and print the values on the screen. So let's close it. So that's it. We have shown how we can print a list of available sensors on our app UI. We can make the first text, this heading text a bit bigger, like text text size. Yeah, click here, and then make it like 25 dp. Yeah, and now if we run, we see how much is the size of our text. And it increased the size of the text of um, all the text that was printed. I think the better way is that we have another text view here on the top, which is list of sensors header only, and we remove this text line and this text size as well. And now if we will this text view will show separately, and it will be just the if you click here, it will be just the heading of the list of sensors, list of available sensors. The next will come here. So we click here, and we see how our app will look like now, the UI. So the app is loading again, and then now this shows not in the right place. Let's fix it again. Go to the text view. Yeah, because I think this orientation is missing. The orientation of our Android linear layout should be vertical. It means that these text views should come uh, the second text view should come below the first one. Now we run it. So that's how it looks now. Perfectly fine. Wonderful. We can increase this text of this size a little bit, but I think we keep it as it is right now. And so that's it. Now what we want to have next we want to have another text view below it, which will give us, for example, the value of the pressure sensors. Value of pressure sensor, and we name our sensor as pressure sensor, our text view as pressure sensor. we can have the size as, let's say, 15 dp, and then we need to define a list view below. List view. To close it. LIS. List view, click here. This will add the list view here. Just write wrap content. No. The height should be wrap content, and the width should be match parent, because so the width is covering the whole screen, but the height is incrementing as the new value for the pressure sensor comes. Okay, let's click here now and let's add the ID. ID should be sensor values list, and let's make it scroll bar, so that when scroll bar should be vertical first of all, because we are going to increase the length vertically, and scroll bar let's see, do we have okay, first of all, scroll bar size, let's say it is 4 dp, and let's select smooth scroll bar and make it true. It will be a smooth scroll bar, and this should go here as it looks good there, and that's it. Now we have our list view. Now we go to our main activity, sensor activity, and we find our list view by its ID. First of all, we should create another variable, list view, list sensor values. Click here, press Alt plus Enter, and you will get Android widget.list view library imported above, or the or the package imported above. And now we need to define an object for our sensor that we are going to access. Name it pressure sensor, and then list all sensors is equal to this is a list view, so we are going to find it in our layout, find view by ID, r dot id dot not list of sensor values list. This is our list view inside our layout, and this does not seem to because this is not our list of sensors, but this is our list view that we defined in the main layout, so we need to have this. Please just cut it from here and place it below here where we are trying to use the find view by ID to to get the views from the main layout. Now what is next? Now next we will get this sensor from the sensor manager class as here m pressure sensor, and then we need to typecast the sensor manager and use get default sensor. This de no, we can simply call this as a function m sensor manager dot get default sensor, and then its type int type or boolean wake up. We can just use the int type and sensor dot type pressure as the integer type of this sensor pressure, and that's it. And now we need to define an array list that will hold the value of these pressure values of this sensor, and array list sensor values array, which is equal to new array list and that's it. We need to have here string, because this will be a string value. We'll store it as string value. And now we need to have an this is actually going to come after these array list symbols. And now we need to have an adapter. The adapter is going to connect the array list with the list view on the alt enter adapter sensor values. And now I will use the adapter sensor values dot I will initialize a new array adapter class, and I'll use the main activity, not the main, it's sensor activity dot this as the first argument. The second is the list view, is the format how our list view will look like. Android dot it has to be android dot r dot layout dot simple list item 1 and comma list sensor values, comma array list. The sensor values array will come here, and that's it. Next we will use the list sensor values. This is our list view from the main layout, and dot set adapter, and we will give the adapter values ADAPTER, and we change the spellings here, ADAPTER. giving an error. This is giving an error. Then the error is Android widget.list view adopter. So because this should be an array adapter, and now this error should go away. That's it. The next step is that we have to register this sensor. We can do it after this. First we can use an if statement to check if the sensor is not null. If we already know from our list that the pressure sensor exists, but this is a very good programming approach. If we check get default sensor, that our pressure sensor actually exists, and that we can only easily check by doing this. If get default sensor, sorry, is not equal to null. If it is not equal to null, it means that the sensor manager returned us a sensor null. And then we can use our braces, and we can register the sensor using the sensor manager dot register. We have to register the listener for the sensor. So dot register the listener for the sensor. If the first value is this class, the second value is the pressure sensor, the name of the sensor, and the third value is the delay, delay, el. Here we can give the time in microseconds. So let's say we give 3 seconds here. So 3 seconds we need to give then 3 and 6 times 0. So 3000 microseconds means 3 seconds. So after a delay of 3 seconds, we will have our new value from the sensor listener. We'll get a new value from the sensor, pressure sensor. Now this function is giving me an error, and let's see what the error is. We should click on this bulb. I think the error is that we need to implement this class sensor event. This class should implement sensor event listener, because Android sensor event listener, because this register listener is coming from the class sensor event listener, and our class should implement sensor event listener. So just put here implement sensor event listener, or you can simply do this. You can simply just cast first parameter. The first parameter can be casted to the sensor event listener. You can also do this, or you don't need to do this. You can simply cut this, remove this, and write here implements sensor event listener. But the sensor event listener should have implement to override two functions from this class. This our class and secretary should implement these two, should override the two functions from the sensor. One is for the one accuracy change, and the other one is on sensor value change, I think. Because let's see what is does implement methods, and we have on sensor changed. When the value of the sensor will be changed, it should be informed, it will listen, and when the accuracy will be changed in the value, it should be. So if we click OK, we will get these two functions written here. So it makes our task more easier. Now we can, in our own sensor changed event, because when the value of the sensor will be changed, we can put the value of the sensor inside our list here. So we will just modify the code here. So the value we will get, it will be a float value. Float sensor value red is equal to is equal to event, this sensor event class object dot values, and it will be a float array, so we will get the value 0. Yes, the value 0, and then we can have declare a text view, and we can dynamically and text value sensor sensor value holder is equal to new text view. That's it. We can add, so this text view will appear on the main activity, so we add sensor activity, which is our main activity, so we add its reference here, and then sen sensor value holder dot append, no, in fact dot set text is pressure value, and simply do this. It should be plus sen sensor value s over sensor, it should be small, sorry, sensor value holder dot to string. This float value of the sensor variable will be then this text view which we created now, then programmatically will contain control alt L, will contain then the value of this sensor. We have properly just indented our code a little bit, and now we will add this text view to our list view. Actually, I think maybe I don't need this. And I can simply call my activity, my list view, which is this list sensor values, and I can say add, and simply we can simply copy this string with the float value of the sensor, and but sorry, we have to use here the array list. What is the array list? This is a sensor value array, the sensor value array dot add. That's it. We can have string value changed, value change for the sensor, changed, and we can simply cut it here like this. Sensor value holder, why my sensor value holder? Yeah, because sorry, because this, it was my sensor value, so I have to use this float value now, and I cannot use toString on it. I think that's enough, and I have to pass this value changed to my array list, and then the adapter ADAP adapter sensor value dot notify dataset. So I put this dataset changed function is called here now for the adapter. The array list now contains this value event value, and now I think everything should work fine. I should have a list that will update itself with the new sensor value automatically, pressure sensor value automatically. And let's see how it works. So our first test, we can have errors. If we have, we will fix them. If not, we'll be happy. So our emulator will be coming up now soon, and it will load the app after installing the APK. Let's see how it goes. Yes, so it is showing the values, which is 70.3 always. So if we change the value, let us keep it here. You see the scroll bar is going down after every 3 seconds. This is the 70.3 pressure value. Now it is changed to 390. Now it's giving 390 value. See it? Value of pressure sensors, and then this list shows 390 value. Now we change the sensor value again to 486. Now it's says 46.0. If we change the pressure value again to 607, now it starts printing 607. If we change it to 608, it should print 608.6. Yeah, it's printing 608.6. So this is a good example of this. We are able to put the value of the pressure sensor in this list easily, and we can do the same for this ambient temperature sensor and proximity sensor. If you say we can check it now for the other sensors, let's go back and let's see what we can do. We can simply copy this sensor object like this and say it's a temperature sensor. P-R-A-T-U-R-E, temperature sensor. And now in the case, then we call it here as well M temperature sensor, which is equal to, from the sensor manager, get default sensor, and sensor type should be type temperature. There are two temperatures, one is the normal room temperature, the other is the ambient temperature. Let me take it as the ambient temperature. And then we will have this list. Now we can have another, we have to register the listener for this sensor as well. If sensor type is type, we should change it to ambient temperature. It's not equal to null, then we should print the value of M temperature sensor after every, let's say every 5,000 microseconds. 5,000, which is 5 seconds approximately. And now let's see, we should also do something here, because now this value can be, this sensor event can be for the temperature sensor or the pressure sensor. So we have to find some way to find out for what sensor we got this value. And for this we can put here some if condition, that if this value is for the temperature sensor is active, then this is active, then this value is for temperature sensor. If the pressure sensor listener is active, this is for pressure sensor, or the pressure sensor value changed. So from this event class, from this event object, from the sensor event, we can also get which sensor type is that. SENSOR sensor, SENSOR sensor type is equal to event object of sensor event dot sensor. So the sensor type will get the, so if sensor type So sensor type dot get type, which is an integer, is equal to our sensor class dot type pressure. Then we have these braces, or the curly brackets, sorry, and then we have we can say that this is a pressure value. We can place it here. These two go at the end. String value changed should be defined outside. That's it. One is boolean, one is integer. Yes, the problem is that we should not have an assignment here. We should have an equal to sign here. And now value might not have been initialized. Let's make it null, or let's make it for identification 0.00. If this is nothing is red, we should get this if there is no value in from any of these two sensors. Now simply copy this and paste it right below, and now change the sensor type to type ambient temperature. Type ambient temperature is here, and now change this text here as ambient temperature value is this. Now we got to run our application again. So now it will print first the pressure value and the temperature value. It will print the values in the groups, because it's going to, because we have both the sensors, so it's going to read the values from both the sensors. It's going to print them in groups. Like first it will print this one. Whenever it will come to this on sensor data change function, then it will print this one, and then you see, pressure value, ambient temperature, pressure value, ambient temperature is 0.0, always in the groups. Now the problem is that ambient temperature value is 0.00. Let's change it to 32.8. Let's see what value we have now. 32.8. Pressure is 608. So let's change the pressure to 997. Pressure is, so it was 89 once during the change, now it is 997. It is 332 is this is 61 the ambient temperature. Now this is 61, so pressure is 997.7 and ambient temperature is 61.0. Again, pressure 997.7 and ambient temperature 61.0. Now we can put it here, 383. Pressure will be 83, and this should be 100. Now the pressure is, so it is at 97. Pressure value is 383. At 97, maybe we had a small stop, and then the value got noted, and now the ambient temperature value is 100 and pressure value is 383.3. So this is a brief description of how our pressure values and temperature values can be read from the sensors inside our device. Now these values are kind of, you can say, stored in our gateway, which is the sensor, which is the Android phone storage, and now from the gateway we can send it to any server or any cloud or whatever. This cloud is also a server, which is web based, and it has a presentation layer, a web interface or something, and it has the database or whatever, storage or whatever. So in the same way, we can simply send it to a PC, these values, a small simple computer, and with the help of a Java application which will be acting as a server, we can read them. Okay, let us now only update the values when they are changed, not after just a certain interval, any value, just when they are changed. So let us see how to do it. Define a string old sensor, m old sensor value, and another m sensor value changed. In fact, name it m new sensor value. So we have now two strings. We go to our own sensor changed function. This is our sensor value. Just do it something like m it should not be sender value but sensor value. In fact, name it m current sensor value. Go to this red line where this shows the error, so we'll get to over this value, and m new sensor value, which is equal to dot to, or make it like float should be capital, float dot to string, and then give the float value and convert this float value to a string value, and that's it. Sorry. Now what we do, in fact, first of all, we can have this new sensor value initialized to nothing, and then we assign our, no sorry, this is current sensor value, now we assign our, this should be also our current sensor value, not new. No, sorry, this should be our new sensor value. Yes. Now we will compare the two. If m current sensor value dot equals, these are strings, so we can use dot equal operators on them, equal to m new sensor value, then do what? Then we have our, let's name a boolean above boolean m sensor value changed, which is equal to, set it to false by default. So if these two new and old values are not the same, we will simply set this to true, this m sensor value changed boolean to true. That's it. So this will be true. So now what we do, now if our, first of all, yes, if our sensor type is sensor pressure, and we also have another if statement here, like we should have add, and if m sensor value changed is equal to true. So now it is a pressure sensor, and if sensor value change is true, in fact we can, because we need to do it for every sensor, then better we have another if statement on the outside, and we put this m sensor value change. If m sensor value change is equal to true, then we go into the next if, otherwise we don't do anything. That's it. And now we have braces open, braces closed. Otherwise we don't update even our array value and and we don't even update our assign notify that after to update the list, uh, so that's how it should be. I think it will work now. Instead of event dot this, we can use actually our new sensor value here, because this new sensor value is actually the same thing in the string format. That's it. So now we just go through the code again. We have initialized our m current sensor value to nothing, empty string. M new sensor value is the value of this thing. This is the sensor data that will read any sensor, and then we compare if the current value is equal to the new value, and this will true. But this will always be true because our current value always will be empty, and this will be the new value. So we need to change something. What we need to change? Yes, we should put here our current sensor value as our new sensor value, and we should assign both of them an empty string when we declare them. M current sensor value is equal to empty string, M new sensor value is equal to empty string. So what will happen? When the control will come here, it will assign the new sensor value, which is an empty string, to the m current sensor value, which is an empty string, on the first change of the sensor value. And then the new sensor value will contain the value of the sensor. So they will both not be equal. And this will be true on the first run. But on the second run, our new sensor value, which is now this value, will be assigned to our m current sensor value. So let's say if it is 1.0, this will also get 1.0, and even if the sensor value is not changed, it will again be 1.0, and then 1.0 will be equal to 1.0, and this will be when they are not equal. Yeah, this should be not equal. Yeah, so they will not be equal, and they will be equal, and this condition is that they are not equal. So the sensor value change will be true, but sensor value change is already assigned true, so we should always at the start say that the sensor value change is false. We should again make it false, before we come into, and that's it. And then we have, if sensor value is changed is true here, only then we go to check what the sensor is, and then pressure value and new temperature value, and that's it. Now let's run it, let's see what happens. Now do we need a timer? I don't think we need a timer now. No, we need a timer because otherwise it'll be very fast. So what is the timer with microseconds? 1, 2, 3, 4, 5, 6. This is 5 seconds. Let's make it 10 seconds. And 0. Now we have 7. Okay. Get 10 and 6 zeros. Okay. So now we run it and we see what we will get. Let's see. The test starts now. Click OK and wait for the emulator to load and the activity to load. So the app is finally getting loaded. Let's see. Now we should only get the values when we change them. So pressure value is 0.0. Now we wait. Let us actually make the delay, because we should be sure that the value is not getting printed when it's not changed, so let us make the delay very less. Let's move the 10, let's make it just 3 seconds. Remove the 10, make it to 3 seconds for both the pressure sensor and for the ambient temperature sensor. Now just run it and see what happens. Sorry, app is getting loaded. It will just start to load now. Our sensor will just print one value. If we don't change it, it will not print any other value, because we have this condition implemented that if sensor value change is true, only then we see if the pressure sensor is, if it's a temperature sensor, and we change the values. We can actually right now remove the temperature sensor for our first test, because that will make it simpler, because only one of the sensors will come, because otherwise we need to make two, because I'll explain you why I have removed right now one of the sensor values. Run again. So this app is now up, and we have first pressure value 0.0, of course. Now let's see. We go to our sensors, we click virtual sensors, then we go to the additional sensors here, and then pressure is 0.0, we try to change the value of the pressure to 102. You see, this is here, this is again 102.3. Now there is something wrong with our app. Let's see what the error is, because it just started printing the values every time. So let's go back to the code. Let's remove the temperature sensor completely, because when it goes to the temperature sensor, because it is also listening, it's also registered, so it shows the second value as 0.0. So we need to first of all remove our pressure sensor from here. We'll add the pressure sensor later again. Just comment it out. Right now, just comment it out. Comment out. Comment this out. So this register listener has not registered the temperature sensor now, and that is it. Now we have only pressure sensor left. Yeah, so I think now it should be fine. It will only print the pressure sensor value when they are changed. The reason was that because we had also registered the temperature sensor, so first time when it ran, it was printing the pressure value, because this current sensor value was new sensor value, which was null, which empty string, and the new sensor value was the value of the pressure sensor, and this was not equal, and it printed that. Now the next time what happened, that the temperature sensor was also listening, so the temperature sensor came here, and it kind of, because this new value was, now the temperature sensor value was current sensor value, and new sensor value were like kind of, if they were both 0, they were the same as temperature value, it was changed, it was not changed, and if it will be changed every time, then it will every time print it, so the better is that we only do it with the one sensor. So I explain you how. Just run it. If you don't understand the problem, I will explain you again. Just let me first run it and show you what happens with the pressure sensor. So yes, this is up and running. You see the pressure's value is 0.0. Now we can open our sensors list again. Click on the virtual sensor already. This is the pressure sensor. Now we will try to change the value and see what. Now let's see, we change the value, it's 76 to 140, it will be 140 now, because when we changed, when we moved a bit slowly, we just had a pause here at 76, that's why it showed them. Now I stop for no matter how many seconds, the delay is set to 3 seconds, 1 2 3, so as soon as we'll change this, after 3 seconds it will print, 300 3000 3 microseconds, 3000 microseconds, sorry, 3 microseconds, no, sorry, 3000 microseconds, which is 3 seconds. That's the delay. This is 300, this is 3000, and then 3000 microseconds is 3 into 10 raised to power 6, it's like 3 seconds. So you see, even now it's still at 140. Now I change it again, suddenly it will print 243, you see, after a bit of delay. So 319, after a bit of delay, 319. So 434, after a bit of delay, 434 point. Now it will stop here again. So this is performing perfectly fine, you know and now I explain you why. When I have the temperature sensor here also listening, so first time the value read is for the pressure sensor, the second time the value read is for the temperature sensor. So every time when the new value is read for the temperature sensor, these two values are not equal, because if the pressure sensor value does not change, say it was 0.0, the temperature values was say 1.0 or 24 at the start. So after a pressure value is read and a temperature value is read, after that 1.0 will not be equal to the new value which is coming here, which is 24 temperature or whatever, 25, and this will always be true and it will always print something. So that was the reason that we were having this always printing, and then and this was also one of the reasons this value was printed here, because this value was not getting changed in the case of, because we had this off, this place was commented off, but the temperature sensor was already listening here. This was not commented off before, in that error, and that is why the value printed here was always, in the case of temperature sensor, 0.0. That's what happened. So now as it is working fine, we can now either try to create a server first. We can use Java program for that. We can create a server. We can use this app as a client app, and it will then send these. As soon as we change the values, it will send the values to the server, and the server will print them. So this will be a wonderful example of IoT. Our server will be our computer. This app will be running on our mobile Android phone. Of course, I mean, we can also show it here right now, because from the emulator we will send to some Java application in Eclipse, and you can then also, it will be like localhost implementation we can do, and you can just change the IP address when you are running in your app, when you're running on the mobile phone, and it will just send it from your mobile phone the data to your computer. But first of all, let's think, should we do the sending of this data to the server, or we can also first try to print a temperature value. Let us first of all send this data to the server, because then we can add more complexity, sending two values or something. So let's see how we do it. No, actually we can also do it for the temperature as well. Let us add some other parameters. Wait a second. This will be actually very simple. We just go up and we change these two. We can assign these two values for the. We can have these three values. Sorry. Control C. We can have these three values for current, temperature. Okay, let it be sensor. Then new temperature sensor value and M temperature sensor boolean. And now we name these two as M current pressure sensor value. Just copy this pressure This is M new pressure sensor value, M pressure sensor value changed. Now we go down and M pressure, because this implementation was all for pressure, this Control Z, M current pressure sensor value, M new pressure sensor value. Just copy pressure here in between, see, because now we have to identify a bit for these variables for pressure and temperature sensors. That's it. M pressure sensor value change. Now what should we do? M new pressure. Now we can simply copy this content and do this thing only in the case once we find out if the sensor is a pressure sensor type. And we can remove this from here as well, including Control Z, including this curly bracket, and move it here. We check this here, if this value is changed, then we print this value, otherwise we do nothing. We print this value on the list, and that's it. And we simply copy this content and we copy them inside the, let's see, first of all, remove these brackets. We have here temp, new temp sensor value. Now we copy this, whatever we did for the pressure sensor to here. We change the pressure to temp, TEMP. Change it to temp, change it to temp, change it to temp, change it to temp, and M temperature sensor value changed should be true here. Now what will we do if temperature sensor value is true, pressure sensor value is true, or we will have an OR here. Where is OR in my keyboard? Or the temperature sensor value is true, because once we will run this function for the pressure sensor value and then it will be for the temperature sensor value. It says variable expected. Now which variable expected? Let me see what is the error here. Let us see. So see the suggestions, constant conditions and exceptions option. Replace OR with AND. Why? Control Z. Maybe we need to have brackets here. What is this error? Yes, because we have here an assignment, we should here have an equal to a comparison. That's it. Now let's run and see. Oh, before we run, we have to again uncomment this part of the code. This was the registering the listener for our temperature sensor, and then we have to get the default type ambient temperature. So after this is uncommented, this get default sensor, and this part where we check if this ambient temperature is not null, that is, it exists on our Android. We register the listener for this, just like, and then we have done the same thing that we did for several. We check if these values are equal, current and new pressure value, and then we assign the new pressure. We assign the new pressure sensor value to the current sensor value. The new value is then the current one, which is read from the sensor, and then we check if these two are equal, like the previous value is equal to the current one, and we do the same for the temperature sensor value. We will have here empty strings before when we assign both of them for the first time. Then this will contain the value of the sensor. Say if it is 25, then 25, this 25 is not equal to the empty string, so it will be true, and it will just come to this check, and this true will be okay because there is an OR here, and it will print the values. The second time when the temperature sensor will come, this value will be, new temperature value will be 25. 25 will be assigned to the current value. The new value will be then read from the sensor. If it is still 25, this will be, this condition will be is not equal. It will be with this condition, this will, because this will become equal, and this condition will not be true, so it will not come here, and the sensor value will not be true again. So, and here we have to, as we have done from the pressure value, we have to copy the temperature sensor value changed boolean, and at the start we have to set this to false again, because we have to again set it to false whenever the pressure value is, so that it's at a default condition, and even in the only in the condition where this current value is old value is then read and assigned compared with a new value, there it should be only changed to true for both pressure and temperature. Now run it, and let's see what happens. Yes, so that's it. For the pressure we have 434.9, for temperature we have 0.0. Let's see what our sensors devices are showing on our emulator in the extended controls panel. So our temperature is showing 0, our pressure is showing 439. Let's change any one of them. Okay, so temperature is changed 2 times. From minus 23 we had maybe a pause, a break, and that's why we were not so fast. So you see, the pressure is not here, only temperature is coming. Now we change the pressure to 486. So the pressure is here now in 486. Now we change the temperature again, minus 36. Should come, that's it. It comes only once if we drag. Let's change it again. Minus 19 should come after some time. Yes, minus 19. Let's change it again. Should be 19.7 plus 19.7. Let's change it again. 45.8. You see, so only our temperature value is coming. It's because only we are changing the temperature, and the pressure value remains the same. Although it's read by our own sensor changed event, the pressure value is read, but because it is equal, always the same as the previous one, so that's why it's not being printed, as we have made this condition. And current sensor value is equals m for the pressure. Yeah, this one, because this is not true. Value change is not true for temperature or for the pressure. That's why it's only for the temperature the value change is true. It prints the temperature values. Now let's try to only change the pressure values. 530, or if there was a break, yeah, 530, yeah. Now 588, 588.4 pressure value. There is no temperature value coming. 665.1, 665.1 next value. Now next 735.5. So that's it. Now I hope you have really understood this project. What when. So let us now add some time information in our readings so that we know when our reading changed, and then the time between between the first reading and the second reading when the reading was changed, that can also be noted, and we know then how long the temperature remained like at this value and the pressure remained at this value, so it's very important. So we need date format for this. Wait a second. Date format, call it date format, which is equal to simple date format, and then we will define our format here. Let it be first of all we will have the day in alphabets, then we will have the day in integer like the date, then we are going to have the month also in alphabets, and then we are going to have the year in numbers, and then we will have again a comma, and next we will have hours, colon minutes and seconds, and I think we should have like this. No, I think we should have these removed and have only one at the start and one at the end, so that's just one string, it's like that. And then let's see what we have in the date format. Let's click the error, create class. Where is the import option? We have this error, maybe that's why we are not getting the right import option, comma, that's it. Now let's see, this should be new date format. Yeah, I know what the mistake is here. It should be date format, not data format. And that's it. Now it's asking to add this. Let's press Alt Enter. And we have Android.text. It should be Java.text.date format. We want to use the Java function, not the Android one. Required Java.text.date format and found Android.simple date format. We have actually removed the. Yeah, we have here also simple date format. Just change it to this class java.text.sim. We'll use these Java classes. Now what we should do next? We should define a string which is date current date time, which is equal to date format dot format should be dot format and object. Which object? Calendar. Java.util calendar dot dot date time. Do we have a get instance? Let's see all these functions that we have. Get instance, yeah. Use this get instance. We have an instance of the calendar, and now use get time, I think, or get date time. Let's see, get time. Yes, and then end of the semicolons. And now our value change that we are passing to the array and then to the adapter so that it is then notified to the list. This should be value change is equal to, first of all, we will have the current date time. Then we should have plus plus. We should have here a space, and then we should have here the value change, which is these values. That's it. Now we now in front of our sensor values for temperature and pressure, we will also have the current time. That's current date and time. Now run it again and let's see what we get. Started running. We have to wait a bit until our emulator runs again. So the emulator is up and running. It shows two values and the time, which is 12:16 at 26 seconds. It has the pressure value 946.5 and temperature value, which is 17.6. Now the ambient temperature value is going in the next line. So let us first let's just name it temperature value so that we have both in the same line. Now run again and see what happens. We will have the temperature value also, the date, temperature value string, and this value all in one line. So the app is getting up. Yeah, that's it. Now temperature value is 17.6 here, and the pressure value is 946.5 in the same line. Now let's see what we have actually. So our additional sensors in the extended controls panel. So this is the ambient temperature. You see it is 17.6. This is the pressure. You see it is 946.5, and that's what's shown here at time 12, 18, and 40 seconds. Now let's change one of them. Let's change the temperature. That's 16.6. So at 12:19, 19 seconds, the temperature value was 16.6. So now wait for a few seconds, and then again 15.6 it says now. At 37 seconds it was 15.6. Now change the pressure value. It will be 562.8. Yes, at 1952. So now it looks better. We have our temperature and pressure values with respect to time, and when we change one, because we had these two at the start, and then we changed temperature 2 times, and temperature came 2 times with the exact time with seconds when it was changed. Same here. And pressure it was. So we can now deduce from this that okay, the pressure value was 946.5 at 12:18, 40 seconds, and at 12:19 and 52 seconds it changed to 562.8. So we can make more get more information about our temperature and pressure sensor values, that when did the value change, between what duration the value remained the same, and everything. And now we can set this information to our server, and then our server also knows at what time, at what date the value was changed for which sensor. This is pressure value, this showing temperature value, the temperature sensor, and what was the value, exact value that was changed. So that is actually, I think, enough for our sensors. The next is that we are going to use this as a client. We are going to have some code into our app here, in our main activity, sensor activity here, that is going to help us connect to this server. Then we are going to create a server in Java using Eclipse, and then from our emulator, this emulator, we will change the values here. This value will appear here, the change value, and the change value will be sent to the server at the same time. and the server will then display it. Okay, so let us now see how we can send the values to a server. So first of all, we create a client here in our sensor project. That's the next step. What we can do, we can create an asynchronous class. We can come here near this inside our main sensor activity class. We are sorry, we are creating another class, uh, public class send. How are we naming the class? Okay, so the class name starts with a capital letter. Send sensor values to server. Extends. This will be an async task or asynchronous class. YNC asynchronous task. And now let us define the parameters. It will have string arguments, an array of strings. The next will be void. The last one, we can have a return value boolean on post execute. This should be void with capital V. And now we have these phrases. Now we have an error here, of course, because we have to implement the override functions. Let's see, this class sensor value must either be declared abstract or implement abstract methods do in background. So do in background must be there. Yeah, now we see this, we clicked here, we see this red bulb or red indication. Just click on implement methods and it says do in background is a necessary implement method. It should return result because we have a boolean here at the start as a return value of this function, so it will return result or null in if we don't want to sorry, if we don't want to return anything, so we'll just return null. So now in this class, let us define a socket variable, socket client socket, client socket, or let's name it sensor client socket. Now click here and java.net.socket, press alt plus enter, and this library will be imported here, will be added here. That's it. Now we come down again. So we try to connect to the server using this socket. How we need to establish the circuit? We need to give here the server IP address, which will be a string, plus an integer, which will be the port. Let's name it port. Let's name here inside int port is equal to 5500. Now what should be our client server address? String server IP. The server IP should be, because this we are going to have a localhost server. We are going to run our server on another Eclipse application which will be running on the same computer. So we should write here the localhost address, localhost, or we should write 127.0.0.1. But wait, because this is an Android Android emulator, so in this case we are not going to write this address value for the localhost or the loopback. We are going to write 10.0.2.2 for the Android emulator, because the Android emulator in the Android emulator, this 10.0.2.2 is actually the alias of the 127.0.0.1 or the localhost address, or the loopback address, when the PC is sending a message to its own port and receiving the message through its own port and receiving the using this client application, we are just going to send the data on this localhost address, which is the alias of localhost as we said in emulator, and send on the data on this port, which is going to be received by a server application, the server application that will be running in Java, and it will receive the message. So we can just put here now as the first argument as server IP. Now it again gives an error. Just click here on the indication, create method sensor client socket. Actually, we have sensor client socket method here. This is no method, this is just a socket object for the socket class. So I think it needs a try catch. Now we have catch here. We should have exception. exp. I think this should be an IO exception. Now it's java.io.io exception should be added on the top in the import project to the libraries. Let's press Alt Enter. This is there, but our error is still there. Yeah, sorry, I did a big mistake. I mean, you need to have to create a new socket object and pass server IP and port as address here. Now it's perfectly fine. So that's how it should have been, Of course, it will then complain for now indented control A, select it and control Alt L. The indentation is now proper when we press control plus Alt plus L after selecting the text. Now what we need to do is we can have here as a logging log.d, use the log class of, and then use here a tag async, assign a string, create a variable tag async, so we'll know that in which class are we now right now, which is equal to send sensor values dot class dot get simple name or get name, which will give the class name as string to this. And now log, to add the log class we need to add android.util.log. We need to import this library, and we press Alt Enter again. Now this should have another argument, comma, and trying to connect to the server to send sensor values or sensor readings. Now we need to enclose this in inverted commas, Control X, and just paste them inside the commas, and that's it. Now if this socket object is created and it's able to connect to the server, we should reach this point, and here we can write connected to the server to start sending the sensor readings. We can also pass this server IP address as a parameter in here, as in the async task, like here, So let us do this. Server IP is equal to params 0, the first of the parameters. Yeah, that's it. And what we can do, we go to our own sensor changed function, override function, and where when we see when the value is changed and we put the value in the list, we also send the value to the server. So we use this class sensor send sensor value to server, send sensor send value to server. Let's name it send to server, which is equal to new that's it. Now we need to sign send to server dot execute. That's how we execute our asynchronous class. And we need to pass the arguments here. First we can pass 10.0.2.2, our local address for the IP, and here we pass the port. Now the port we have already passed here, so we can pass the value that needs to be sent. Just pass this value changed as a second argument here, and the value will be sent. Now we can, I think in the meantime, try to create our server class and see if the connection first of all works or not. Wait a second. Just go to the Eclipse. Write Eclipse here in the start menu and click here on Eclipse Java Neon, and this is going to open Eclipse for us. Click OK. So the Eclipse is open now. Just go to File, New, create new Java project, and name it Sensor. Sensor values server, sensor server. So instead of this server that we'll create here, we are going to have a web server or a cloud in the real case, or we can also use this as a server. It's not necessary that we have a cloud application in the IoT ecosystem as a third party. So just create a Java class, new, click here, go to Java class. This is our project, sensor project that we created. And now sensor values receiver is the class name, and click finish, and this is our created class. So now we need a main function. So we write here public static void main. This is going to be our main function. It's going to have an array of strings as arguments, and then we close the brackets, and now we will have a server socket class object name it sensor server, name it sensor socket, which is new server socket, and inside we have the port on which the server is going to listen to, but this needs to import the library which contains this. How? Because it says import, let's see, create so I think this should be described in our main function first of all. Sorry, because only the variable is declared there, and we should have here string, array of strings is defined like this in Java. The brackets come here, and we should have an exception handling, throws exception, and now we have no error. You see, now it is fine. It was missing this exception. We can have a try catch here. We can use throw exception here with our main function. Now we can have a print statement here, sys system dot out dot print ln that says waiting for the sensor client to connect. Then the next will be, we will use the socket class, and we say server socket accept let's name it socket accept, because this is going to use the server socket variable to accept the client connection. That's it. Server class is a server socket object. I mean, it is going to use this socket object, and it's going to accept the client. This started only this connection to this the server socket started listening to this port to any of the client connections. So to accept them, we use this socket class, and then we use the server socket dot accept function that returns us a socket object, which is the connection also, which maintains the connection between the server and the socket. So now we should copy this print out statement again, and we should write here that the server is connected. Sorry, the client, we can name it sensor client, is connected to the sensor server. And we can test until this, if this is working fine, if we are able to connect or not. So first of all, we run this, go here and click on, this is our, or we can just simply click on this class. This class is the main function, so just click on run as and run as Java application, and this is waiting for the server client connection. So we are here, the server socket is created, and we are listening to the server client to connect. So if we go to our application, our Android application, it is going to connect to it, to the server, and show up this one. So and it's going to try and send the values. Let's see what happens. Now we start this and wait to come up. So the so our application will up. It will so this asynchronous class, the client will be started, and this client is going to try to connect to the server on the port 5500. The server is also listening to the port 5500 in this Java application. So we are going to later then send values from our Android app to the client. So let's just see what happens. When the client will be up, we should get this value here that the server client is connected to the server. So we need to wait a bit more. Is coming up. Sent the value is shown here, but the client is not yet connected. Let's see what happened. Yeah, maybe because the value is not changed. It was the first value, so we need to change the value so that we come to so that this is true. Either pressure value is changed or sensor value is changed, and we then have a change value, and then we send that to the server. So let's see. Yes, let's bring the Java server up. Now click here. Yes, now this is here. Virtual sensors and addition sensors. Go to the pressure sensor and just change the value 2.0. And let's see what happens. Oh, sorry, I changed the proximity value, not the ambient pressure. I need to either change the temperature value or the pressure value. So let's change the pressure value. And now this will appear. Yeah, the pressure value is here, but the client has not yet connected. Okay, I changed the temperature. The temperature value is here as well, but the client has not yet connected. So let us see what happened. Trying to connect to the server to send server readings. So it did came to this class and tried to send the values, but this somehow failed. 10.0. We can print what sensor IP address we have here. Make it plus. In fact, trying to connect to the server should be here. Plus plus. No, should have in between the server value here. Right here. In the same way, we should have it here connected to the server to show to which server it is connected. Let's see, that's it. So let's see what happens now. We restart. Yeah, we saw here, right? Because one of this trying to connect server message was printed, but connected to the server message was not printed. So we were here when we changed the value of the temperature and the pressure sensor, and the value got updated on the screen. And then we came here because when we change the values, we are actually calling our sensor class. So we are again now starting. We just printed the sensor value inside the message to see which, sorry, the server IP in the message to see if the server IP is right, and then see what happens. Our server is still waiting. So the client is up again. Let's change the value of the sensors again. Let's change the value of the temperature again. Okay, it appeared. Now see what we have on the. So trying to send to the server 10.0.2.2. So the server is right actually. Let us change the port. Maybe the port is, if we change the port, maybe this port is not 8020. Let's say we change the port to 8020. We also listen to the port 8020 here. We stop our server again. No other server is running. Yes. So we just click again, do a right click here, go to run as Java application, and we wait until the server is running again. The sensor values class, child receiver class has a main function, so just clicking on this class will make it run. So our server is running again. We need to run our client again now. Not this. We need to run our client case in this project. We can delete these old messages by clicking here. We can delete these console messages, so they are deleted. If we click here inside the Android monitor, and now we'll have new messages. Wait, we need to change the port to 8080, not to 8020, but let's try 8020. Let's change the value of any of the sensors now. Let's change the temperature value now. It's changed, and we don't have any other thing again. We just have this trying to connect to the. Okay, let's change the value to 8080 because people use this often as the client port for the client server communication. Now stop this, run the project again. Run our client again now, once more, and then wait. Yeah, so we are still stuck at trying to connect to this. So one important reason can be we have not really put in our permissions for our app. For example, we need our app to access internet or Wi-Fi state. Only then we can communicate with our server. So let's add permissions. Android permissions. Let's see how we do it. Just go to Google and type add internet permissions Android. Okay, just click here, how to add manifest Android permissions, and we see how can we do it. Yes, simply just copy this line above your application tag inside the manifest file. We have discussed about the permissions before when we were talking about the topics more theoretically. So just add these permission here. For internet, simply also copy paste it and add the permission for the network state, for the Wi-Fi state, and also for the change Wi-Fi state. So just change this to dot access network state, access Wi-Fi state, and now we have dot change Wi-Fi state. Now for Android version API 23 and above, we should also define the we should also access these permissions inside our main activity class. Before we could only use them in the Android manifest file, and that was enough. So we need to also, we can add the permissions here for the Android API 23 and above. Simply add an if statement and an if statement. build dot version dot SDK, which is greater than, or the API level greater than 23. We need to assign the permissions here. Else we can have a log dot debug message, which shows that the permissions are granted. Permission is granted. That's it. We need to add it should be log, not log. It should be log. That's it. We need to have 2 arguments here. Let's put a tag here for this class as well. On the top, string tag is equal to sensor activity dot class dot get simple name. That's it. And we add this tag at the start because this shows that this message is from this class. And this way we can also have 2 arguments, the required argument that we have here. Now here we should assign the permissions. This activity compact dot request permission. Now here we need to put which permission is required and then the permission code and the request code. This dot new string, it's a string array, and we need to provide permissions here. This should be manifest dot permission dot access internet, let's say first, and comma 1. This is the string array. This should be actually like this. That's it. So this is our context, comma new string. So that's how we grant permissions. Actually, we can, even for the higher version, we can check if the permission is already granted, and we can do it like with the self check or check self permission. I think check self I think the check has C small. Check self permission is, then check this permission manifest. We can simply copy this from here. This is check self permission. That is going to check this permission. There needs to be a bracket here as well. Is equal to package manager dot permission granted. So if the permission is already granted, we write the same thing again, that the permission is granted, else we force to grant permission, and then we also have this else statement, and this can also be like this. That's it. So that's all what we need to do. Just select this and do a proper indentation. Control Alt L, indented. Now the L should go here. This L seemed to be in error because we need to have this, I think. That's it. So if the SDK or API is greater than or equal to 23, we check if the permission is already granted. If it is granted, we print permission is granted. If not, we grant the permission. And then else we grant the permission. Okay. The next is we can simply copy this part, paste it, and just change this internet permission to dot access Wi-Fi state. Just copy this to here as well and at those places. So the Wi-Fi is also granted. Wi-Fi like this, the Wi-Fi permission. Control C. So just copy it, Control C, and paste it again, and now change this Wi-Fi to dot access network state. Just change this here also to access network state. And here we change to change Wi-Fi state. Change Wi-Fi state. So that's how these, I think now it should be able to connect. So all the permissions are granted inside our main activity as well, also in the manifest file as well we have all the 4 permissions granted. Now first of all go to our server again. Our server was, don't need to delete this. Okay, our server was only this one. It is already waiting, it's running. So let's see what happens now. Sorry. Now let's see what happens now. We run it again. And now you see our client is up and running and the sensor client is connected to the sensor server. We are at this message. So it is now working. Every time we will change the value, it's gonna connect again for the first time as well because the values are different. It's changed. Now we change the value. No, because the server has to run again. That's why. So we need to run the server again. The server is running again. Now we change the values. Okay, this is now there is some problem because when we change the values we are not able to. No, it is connected, but it took some time. So let us change the value again to the next one. No, of course it's not because it's again. So we have to kind of, place a while loop here, while so that whenever our server is connected, it disconnects and connects again while true. Now we need to disconnect sensor so that it's ready to connect again. So socket.ti. No, socket accept dot. I think that is not needed. We just need to. That's it, and we can put this out of the while loop, and that's it. Now if we run our server, just remove this, Control S. So now if we run our server, that's it. And now we go to our sensor project, we run it again, see what happens. Came 2 times, waiting for sensor client, sensor is connected, waiting for sensor, sensor is connected, and then again, because there were 2 values. Now if we change the values, we'll see what happens. The value is changed, and you see it connected the 3rd time, and then it's again waiting. Now if we change this value of temperature again, you will see it will connect for the 4th time. Yes, it connects for the 4th time, and it's again waiting. Now we can modify our sensor project to receive data from the receiver. Let us first change something on the receiver side to send the data to the server. We go to our receiver code, our sensor activity. Now we go to our client process, which is send values to the sensor, and it is connected, and here we will try to send the values. So first of all, we'll have 2 strings. One string is going to contain the string value to server, which is equal to our parameter 1. Remember, we can now pass we have already passed this IP address to the parameter, so we can put this parameter 0 value here, so IP. So the parameter 1 is our value to be sent, which is going to be the changed value, as we have assigned the changed value here. You see the value change is our parameter 1 for this asynchronous task. And now we have string value received. No, we will just get an acknowledgement from the server, acknowledgement received. Now this is the acknowledgement received. We can use the data output stream to send the data over to our socket, data output stream class, and the output, or let's say output to server, which is equal to new data output stream and socket sensor client socket dot get output stream. Now we need to create the input stream reader to read the input data from the socket. Input from server, which is equal to new input stream reader sensor client socket dot get input stream. That's it. Now we store this into the buffer reader input received acknowledgement received is equal to new buffer reader, which gets input from server as the input argument. So this is already defined. So acknowledgement buffer read received, you can say. Sorry. So now we can simply, using out to server and input from server, we can easily receive the values and send the values. So value to server is equal to out to server dot write bytes, write bytes, which is a string. Let this string be this parameter one value, which is a change value from the server, plus add this slash n because it ends at the ends reading at the ends writing at the slash n, so this is important. Well, we have this error. Okay, found void, required this incompatible types. Yeah, sorry, we don't need this because we are already sending this value. The value received is done like this. For example, how we get the how we receive the value from the input stream reader, if in the buffer reader, that's how we do it. Like acknowledgement received from the server, which is equal to acknowledgement buffer received dot read line. That's it. And now we can use this to print this value. Acknowledgement is received from server. This is the server IP address. So this is the acknowledgement received. Add plus here. As this is the acknowledgement received. For the sent value, which will be the sent value is value to the server. For this value, we received an acknowledgement. So that's it. That's how it works on the client side. Let's go to the server side and let's see what we can do there. What we did here, we can actually reverse it on the client side. For example, we can copy the same things. We can paste them here. Out from server, in from client, and the socket in this case is the sensor socket, which is gonna get the output stream, which is the out from the server thing, and this is the in from the client thing. And now what is the in from client should be here. Yeah, so this buffer will be the input from the client. So that's it. So we did it. Now we have still some error here. Yeah, the reason is we need to use this socket accept, not the server socket object for this, and now this error is gone. Now because the server is first going to receive the data, so we can put these two lines above, just the other way around as in the client. The client was for sending the data, so we are the other line above. So when the value is received, we can here write as data received. We can simply use this print line statement and use the string data received inside our println. The received data is this, and now we can out from server. We can write here, no sorry, it should be a string. Data string received, which is equal to data received, because the buffer should get this dot get dot read line, dot read line. This will give us a string that is received. String data received should be together, and just copy this string in between. So this is the value received, and now just print here that acknowledgement is sent. Okay. Acknowledgement is sent back to receiver. And that's it for this. Now we have an error here, just we missed one semicolon. And now we check. Yes, we have an input stream, data stream. We get the input data stream from the socket. We have a buffer, we pass it to the buffer, and from the buffer we read it into a string, and we print the string, and then we send the output data from the server. We have to write this to the socket. Output, just like we did in the receiver side, output from server dot is there a mistake in the spellings? It seems yes, this is small dot write bytes, dot write byte, which is string, yes, and simply write the string thanks sensor value received, and then plus add a new line corrector so that the receiver buffer knows that the value received is finished. /n. That's it. Now we can run our server. Just click here again. Just go down, run as our application. The server is running. Now we run our client and see what happens. Our client. Emulator is starting. Almost started. Now we can go here. We can bring the emulator up here, and then we see how the client server communication will work. Hopefully everything will work fine. If not, we will fix the error and make it work fine. The app is just going to load up now. It's up and running, and you see it already received two values. Sensor data, first of all waiting for the client to connect to data, then sensor client is connected to server for the first value, then received the value of the received data is Tuesday 11 July at 11:36, pressure value 0.0 and temperature value 0.0, you know. And then it sent the acknowledgement back, and then waiting for the server to connect, and then again it's connected, and again send it, then it sent the acknowledgement back, and then waiting for the server to connect. So we can see on the client side what happened. On the client side, same happened, trying to connect to the server to send sensor reading, connected to the server to send, and then trying to connect, and again connected to the server to start sending the readings. So it's just because we are not printed when we send the readings, and that's it. Sorry, we were reading the old emulator values. I think we should be here, and here it really shows that this statement also is printed. Acknowledgement received from the server. Acknowledgement received from the server as thanks. This is received from the server, thanks. Sensor value received, and for what? For the sent value. this sent value, the sensor value received, and then again thanks received from the server for the sent value. This we can differentiate this, that this is the value by having this before and after it. Okay, sorry, as, and then we will have this message from the server, and then this will be more clear. So that's it. That's how it is going. Let's run it again with this. Because our server is already waiting, we don't need to start our server again. Just wait until the app is up and it starts sending data. Again, the app is up and receive the data again, this time at 12:15 and 6. Last time it was 12:11 and 6, these two values. And now we have until these three, these are the values for the new. And now it is again waiting for, now we'll change the values and we'll see if we receive the change values like this. So we go to the receiver again, sorry, the sender again from the client who is sending these values, and you see first of all it says that the acknowledgement is received from server this as thanks to the sensor value received, and for this sensor value which is pressure, and then again acknowledgement received from server 10.0.2.2. Actually this is the same thing as client, it's the local, so client and server have the same IP address right now, and this is for the sent value and for the temperature. Now let's see how we do it for the other values. Just go here, go to the virtual sensors, for additional sensors, change the temperature value to say 42 and wait. You see, there is another value that is received. It is printed here, Tuesday 11 July 2017, 12:16, 18 seconds, temperature value 41.4. Sensor client is connected to the server. The received data is Tuesday 11th July 2017, and this is the time and the temperature value. This is the temperature value received. Now we do for the pressure. You see, as soon as the pressure value is printed here, it is also received here, because it got changed 2 times because we maybe were slow and we paused in between, so it has printed it twice. The value 262 at 12:16:45 and 12:16:48, the value 307.5.0. So so this way we can have maybe any other server, we can have a web application here to beautifully write this data, or we can write this data in a database, and then from the database we can read this data, these temperature values or pressure values, and we can print them beautifully on a web page or on a cloud server page, server web page, so it will be you can say a cloud. What is a cloud? Cloud is just a web server. Like, it has a database, it has a computational power, it has a presentation layer, to present the thing. So we can also do certain manipulations on this data. We can, see the variations of the pressure and temperature and make graphs and show those graphs on a server. So that's you can do anything. So you can play around with this, and you see that it will keep working. You see now 2729.1 is received. It's also printed here. Now you see 850 will be printed. 850.6 is printed. You see now 8185.5 is printed for pressure. Now the temperature, you see minus 120.8 is printed with this. This is now minus 273.1 is printed. And if you see, this is also going down in this list, and that's actually a beautiful example of a complete ecosystem, a simple example of an IoT ecosystem, because we have here sensors. These are our sensors on our Android device. This is our, you can say, gateway, and this is our server or a cloud, you can say, this, if we just make it a web application. So that's it.